Force have been our main topic for the past sessions. Now, we will look at the development of the relationship of force and motion concepts over time. Specifically, you, by the end of the lesson, will be able to compare early views of force and motion, trace the development of force and motion concepts, and relate force and motion. Let's begin. In the past, people also wondered about why objects move, what's making them gain speed. Aristotle, a Greek philosopher, stated that the natural tendency of a body is to remain at rest, and that force was needed in order for things to move, or, if already in motion, keep it moving. This was believed by most people as he was the most credible person during his time. According to him, there are two types of force which drives things into motion. These are natural force and violent force. This knowledge was anchored from what is observable around us. Natural force makes objects rise or fall, or it is a force which is followed by objects on their tendency to seek and remain in their resting position based on which the element they are made from. These elements are namely water, fire, earth, and air. If we are to observe, what happens if we let go of a cup of water? It falls downwards, right? How about if we boil the water? To which direction will the steam go? That's right, upwards. Objects move to where they are supposed to rest on, and according to Aristotle, objects are influenced by natural force. Objects made from fire and air tend to seek rest upwards, and objects made of water or earth will seek to the lowest ground. This was their idea since the concept of gravity did not exist yet on their time, thus further concluding that objects gaining speed and objects falling gains weight. Force wasn't really that clear yet on their time. On the other hand, violent force refers to somewhat unnatural movement of objects. Any movement resulting from an action of other objects are caused by violent force. Example, collision of objects. Violent force influences objects to move, and thus, this can be described as an external influence in motion. For generations, this was believed by many, though there are some truth to some concept. Galileo in 1589 tested these claims. Galileo was famous for making experimentations on the Leaning Tower of Pisa. He concluded that objects fall in the same acceleration, and thus, mass doesn't have anything to do with their gain of speed. Galileo also studied the concept of acceleration using spheres in plane, where he concluded that objects rolling downwards gain speed, while objects rolled upwards loses speed. Contrary with Aristotelian theory regarding the natural tendency of objects to seek and remain at rest, Galileo claimed if we were to roll an object in a slope, the ball will reach the same peak as its starting point and will continue to do so. Objects will be in motion forever. The tendency of objects is to continually move in plane, and no force is required to keep objects in motion, at least in an idealistic world where friction does not exist. Later, Isaac Newton took all these ideas in making the book called Principia. He came up with the famous Newton's laws of motion, to which he acknowledged the early thinkers for studying these concepts. Aristotle said that the natural tendency of objects is to move to their resting state. This was later clarified that this was because of the concept of gravity. Galileo, on the other hand, insisted that objects, regardless of their mass, fall at the same rate. Where in the real world, if we try to let a rock and a feather fall at the same time, they will never reach the ground at the same time. But then, he was right. They did not reach the ground at the same rate because there was friction. Newton comprehensively took all of these ideas, which we will look at in the next session with Newton's laws of motion. To recap, you learned about the early views of force and motion, the development of the concept of force and motion, and the relationship between force and motion. Let's check what you've learned. Try to answer the following questions. What are the early assumptions of force and motion? What are some of the most notable concepts of force and motion? And what is the relationship between force and motion? And for your takeaway, Newton was one of the most brilliant scientists until now. He may be credited for his analysis on force and motion, but he never forgot to acknowledge and appreciate those who, in one way or another, gave him ideas in completing his work, the Newton's law of motion. He said on his remarks, "If I have been able to see further, it was only because I stood on the shoulders of giants." With that note, thanks for watching. I appreciate your time and I shall see you again on the next one.